Hangi enggak?
Oi. Good morning. Am I properly audible, guys?
Yes, ma'am.
Am I audible? Okay, okay. Okay, we will wait because there are so less students are there. We will wait just 1 to 2 minutes. I just want to revise whatever we have done in last time. What we have seen the brief history, then the 80386 architecture, then what is the difference between 8086 and 386, data types we have seen. Now I think we will start. We are in a programming model of 386. Am I right, guys? Yes? Okay. We are in the programming model of 386. Now in programming model, we have seen the how it means what are the parameters in the programming model. The first one is what you have. Yes, what do you have? Let me know. What is the first parameter in a programming model? I think whenever I'm giving the deliver the lecture, you should know or you should have your own notebook and pen with you. Okay. Okay. In the programming model, first the parameter is the memory organization. Second one is the data type. Third one is the register. The next one is the instruction format. Then the operand selection and the interrupt and the exceptions. Okay. So amongst that, we have already gone through the memory organization and segmentation, data types. I think we are in a registers. We are in a registers. Let me share my PPT. Okay, my PPT is visible to you? PPT is visible, guys?
Yes, ma'am.
Yes, ma'am.
Okay, okay, okay. Okay, I think we are in a flag registers. Okay, we are in a flag registers. Now, what is the purpose of flag register? Anybody know? I think we have seen the what are the function, what are the use of registers. The basic definition of registers we have already gone through that. Okay, but why you need what do you mean by flag? What do you mean by flag registers? Anybody know? Huh? Let me know. Anybody know about the flag? Flag. What do you mean by flag?
Oh, in which jealous.
It contains current state of CPU, maybe.
It contains the
Current
it,
current state of CPU.
current data. I can't hear you properly. Who is speaking? Let me know the name of that. Yes, you are right. I can't hear
Ma'am,
you.
it's Abhishek.
Huh?
It contains current state of CPU.
Current status of CPU. म्हणजे whatever the instructions has been executed after the execution of each instruction. I think the instruction you know very well. The whatever the we are giving some command through the keyboard to the machine, that will be the instruction. Okay. So whenever after executing that instruction, what are the content, what are the status of each and every register? Okay, that will be the flag register. Now in Create6 microprocessor. Yes, anybody has any doubt? Anybody has any doubt? I think no doubt. Okay. Now, the flag registers of Create6 microprocessor is a 32-bit. That is 0 to 31. Okay, 0 to 31. We have already seen the 8086 flag registers. Okay, some flags are common between the 8086 and 386. Okay, so we will just go through one by one. At the 0th bit, that means here. I think. पेन यूज करके जरा you will get it. Okay. My screen is visible to you? All of you? Okay. Yes or no guys? Speak out. चहा वगैरे पिला की नाही? सकाळी नाश्ता वगैरे केला की नाही?
Yes, ma'am.
हाँ. ठीक है. Okay. Okay. Now this is the at 0th position. This is at 0th position. So you have the total 32 bit, that is 0 to 31. So first one at the 0th position you have the carry flag. At the 0th position it is a carry flag. Now this is a E flag register. This is a E flag register. Why it is E flag register? Because it is for 386 microprocessor. Okay, and for 386 microprocessor it is a 32 bit microprocessor. That way all the registers are extended. Flag registers are there. Okay. Now in the programming model, why they have included this? Because after the execution of each and every instruction, it gives the status of memory. Okay. Now the first at the 0th position you have a carry flag. Now this carry flag will be set. Listen carefully, guys. This carry flag will be set by the arithmetic instructions, like you have add, delete, subtract, multiply, divide. These are some arithmetic instructions. Okay. Now whenever after the execution of these arithmetic instructions, when it generates the carry or a borrow, then this bit will be set. Got it? Otherwise it is simply cleared, and this particular carry flag will be inverted with the which instructions, like you have the STC, CLC, CMC instructions. See, you just remember this word STC, CLC, CMC. That is clear the carry flag. And just remember this instruction, because after this programming model, I will take what do you mean by instruction, how it gets executed, and all this. How many types of instruction sets are there? That will be the next part. Okay, so the carry flag will be set by after the execution of arithmetical instruction when there is a carry or a borrow. I think you know carry and borrow. Okay, very well. So whenever there is a carry or the borrow is generated, then this flag will be set. Otherwise, it is simply resetted. Okay. Now next bit. That is the first bit. By default, this first bit is undefined. See guys, this whenever I am saying this is undefined, okay, like I have written over here 1, okay, for the first position. That means it is undefined. That is, it indicates the reserve. Means, for example, suppose you have a latest version of the microprocessor and somebody want to reserve, somebody want to assign that bit. Okay, somebody want to use that bit for any purpose, for their research. Okay, so they can use that bit. Okay, so that is the, by default it is the. But now see, whatever they have given, you have to consider it, you have to accept this. Okay, because you are getting the concept of microprocessor, that is the thread 6. So get it understood, what is the concept of thread 6 microprocessor. Okay, now the next bit, that is 0, 1, 2, the second position, that is the parity flag. Here you have a parity flag. See here, parity flag. Now when this parity flag will be set, this flag will be set by the most instruction if the least significant 8-bit of the destination operand and it contains the even number of 1 bit. Okay, that means this flag it is set when there is a even parity. आता madam, even parity म्हणजे काय? I think you know even parity. Anybody know about the even parity? What do you mean by even parity? That means it contains all ones. Even parity. That means 2 1, 4 1, 6 1. Even parity. 1 1 1. Okay. So this flag it is set when there is a even parity. When there is a even parity, that means it represents the number of 1 bits in the lower byte only. म्हणजे बघा आता फॉर एक्झाम्पल तुमचा आता असा आहे. Let me give the one example. Suppose this is a 0 to 8 bit, okay, 0 to 7 bit, okay. Now the lower 4 bits and upper 4 bits, okay. Now in upper 4 bits, okay, in upper or the in not upper, in the least significant bit, if there is a value something like this 1 1 1 1, that means it is a even parity. That means 4 ones are there. Okay, so in the least significant 8 bit. Now this is for 8 bit, like this is for 8 bit. Now for 16 bit, lower 8 bits. For 32 bit, lower 16 bit. All are 1. Then this parity flag will be set. Understood, guys?
Yes, ma'am.
Okay. Now the next is the auxiliary flag. नहीं, उसके बाद I think it is a unreserved. Parity flag, okay, 1 digit has been gone, like the first bit, like it is undefined, okay, or the reserved for the Intel processor. After that you have the auxiliary flag. Now this flag is like the carry flag only. This flag is like the carry flag. When the carry is generated or the borrow is generated, the carry flag will be set. But this auxiliary flag is set when there is a carry or the borrow is generated from the most significant nibble of the least significant byte of the accumulator. Okay, let me explain this one. Okay, now you have, suppose 8 bits. Suppose you have 8 bits. Suppose A 0 0 0 and 0. Okay, and then here 1 0 1 0. Okay, now whenever you are doing some calculations are there, it may be some, here you have any value, and if there is a, now 1 plus 1, how much it is? How much it is?
0 carry 1.
0 carry 1. Okay, so that means what? From the least significant digits, there is a carry is generated, and then this flag will be set. That is the auxiliary flag. Understood? Now next, after the auxiliary flag, again the user defined or the undefined flag bit is there. Okay, now next is the zero flag. Now this flag is set whenever the result of the operation is binary zero. Okay, that means whenever you have got the answer is zero, this flag will be set. Otherwise, it is simply resetted. Okay. Now next, after that zero flag, there is no bit is reserved. Then you have the sign flag. Okay, you have the sign flag. Now the sign flag is the seventh bit. Now when this flag will be set, the result of the bit 7, 15 and 31. Okay, this whenever the answer is negative, okay, then this flag will be set. Okay, otherwise this flag will tell whether your answer is positive or negative. When it is a negative, this flag will be set. When it is positive, this flag will be resetted. Okay, but this flag will be depending upon the magnitude of the 7th bit, 15 bit, 31 bit. Why I am saying it is a 7? Because 8 bit, 16 bit, 32 bit. When there is a carry generated, then your answer is negative. Am I right? Yes or no?
Yes, ma'am.
Okay. Now the sign flag will be set when your answer is negative. Now after that, there is a no bit is reserved. After that, that is the trace flag. Trace flag. TF, which is the 8th position. Now whenever the actually here you have the concept of exceptions is there. That will be the concept in your the 4th or 5th unit, I think so. But get it understood for now. This flag, it allows you the single step through the programs. Okay, it execute only one machine instruction. Trace flag. That means, see, you know the debug procedure. Now in the debug, when you are debugging your program, debugging means what? You are line by line you are debugging your program. Line by line means you just keep the debug and you are executing your program. That means what are the content of next register, what are the content of variable. Okay, debug. So whenever the processor detects this flag, okay, or this flag is set, it executes one machine instruction and it automatically generates the internal exception 1. Okay, madam, internal exception 1. Now exception is something like the error. Get it understood? First, just remember exception is something like the error. Okay, so that is the trace flag. That means when there is a debugging is there through the single step and it executes one machine instruction. When debugging operation is done, okay, you debug the instruction singly or step by step. It generates this flag will be set of the reset. Okay. Now the next flag is the interrupt flag. Now next flag is the interrupt flag. Now interrupt flag is set when the thread 6 handle the external hardware interrupt. आता madam, interrupt म्हणजे काय? What do you mean by interrupt? That is again your 3rd or 4th unit. But just remember the interrupt word. It is something like that. I think I have given one example that suppose you are studying and your mom has given the instruction that just go to the shop and get this thing. Okay, that means she is interrupting you. She is disturbing you. Okay, she is interrupting you. But after finish that work, you will be continue with your study. Okay, so that is a concept of something like the interrupt. Okay, that I will tell you whenever we have that particular concept. Okay, but just remember interrupt flag. Yes, anybody has any doubt? Let me know. I think no doubt. Okay, so interrupt flag. Thread 6 handle the external hardware interrupt in the INTR pin. Now 386 having the INTR pin. We will see that pin diagram of 386 microprocessor. So 386 microprocessor, it has, yeah, काही problem नहीं है.
नंतर काय आहे मला काही काम नाही आता.
Okay. Now the 386 it has the external interrupt. Now what do you mean by external? So external interrupt is something like that. Whenever there is a INTR pin is there for the IC, okay, for the IC, and whenever you connect external wire to the INTR pin, that means you are giving the external interrupt. You are giving the external interrupt to the processor, and when that interrupt is given, then this flag will be set. Okay, and that means you can attach an external wire to that. Okay, so that is the external interrupt. That is the external interrupt, and when there is some connection is given to that particular pin, this flag will be set. This flag will be set. That is the interrupt flag. Now next is the direction flag. Next is the direction flag. Direction flag. You know the string instructions. You know the string instruction. Not instruction, like the string operation. Like you can add the two string. You can find whether the string is palindrome or not. Okay, although you want to find the substring of the string. At that time, what will happen? That this flag, direction flag, will be set. It depends upon your applications. It depends upon your application. So direction flag will be set and cleared by there are two instructions mostly. That is the STD and the clear the direction flag. That is the CLD. And the whole purpose of this direction flag. It determines whether the string operation, like you have, whether you have to find the length of the string, whether you have to increment the length of the string, something like that. In that operation, the direction flag will be used. Okay. Now the next is the overflow flag. Overflow flag, that means when there is a suppose you have a 16-bit processor and your answer, you have got the answer near about 17-bit, 18-bit, then that means there is a overflow flag. So when this flag, the result is more than whatever the bits, okay, the result was at least 1 bit too large to fit in the destination. Okay, that means it has a 1 bit to chalta hai, that is your carry or borrow is generated. But if your answer is more than 16-bit, 18-bit, 20-bit, so this flag will be set. Otherwise, it is simply resetted. Okay, that is the overflow flag. Now, the next bit is a IOPL. Next bit is a IOPL. Now, that is the 2-bit. That is the bit. That is the 2-bit. IOPL is I think, bit number 12 and 13. Okay, it acquires the 2 bits. Now, what is the IOPL? That is the input-output privilege level. Madam, आता privilege level काय आहे? That have the concept in second, third or fourth unit. But just remember this one. When this bit is, see, 80386 has a 3 modes: real mode, virtual 86 mode, and protected mode. Okay. So whenever there is a protected mode instructions, it gets executed by the processor. Okay. Whenever these instructions are used by the processor, these flags are set. That means this flag will hold the privilege level of that processor. At which privilege level the processor is working. Okay? At which privilege level this processor is working. So that means when it is a 00, it is a privilege level 001, it's a 1. 10, it is a 2, and within 1, it is a privilege level 3. Okay, so that will be the something like that. That is the IOPL. When the protected mode instructions are used by the processor, and at that time it holds some privilege level. So that kind of what privilege level it holds, that kind of information will be getting from this particular flag register. That is the IOPL. Okay. Now the next flag is the NP bit. That is the nested task flag. That is the nested task flag. Task flag. Now, when this flag is set, it indicates that one system task. It indicates that whenever the one task means what? It is like a one program, or the you can say one work is there. A set of instructions are there. Okay. Now one set of or the one system task, it gives or it invokes the another system task, like the calling procedure. You know the calling procedure. Suppose I have written one C program, and in that I have to call some procedure. So I will write the call and I will give the name of that procedure. That means the calling procedure. Okay. So when that instructions get executed, this flag will be set. That means the program or the processor is calling the task within the task within the task. Okay, it may be calling the subroutine, it may be calling the some procedures. Okay, that means within one task he has executed, but within that task, within that procedure, there is another task, and he is switching from one task to the another task. Okay, so at that time this flag will be set. Okay, otherwise it is simply resetted. Resetted. Now next is the nested task. After that you have the again the one bit is leave, which is again user defined, or it is a reserved bit. Okay. Now the next is the resume flag. Now this flag, resume flag, this flag is related to your debug. Okay, when debug registers are there. We will go through that all the registers set of 386 microprocessor. So there is a debug registers DR6 and DR7. So when this flag is set, whenever the debug registers DR6 and DR7, it has some exceptions. Okay, it has some exceptions. Then this flag will be set. Okay, so this flag is related to your debug feature. Just remember this. Whenever the debug feature is there, and whenever the DR6 and DR7 registers, okay, it has some exceptions, then this flag will be set. Otherwise, it is simply resetted. That is the resume flag. Okay. Now next is the virtual mode. Very important. This is the virtual mode. That is the 8086 flag. Okay. When this flag is set, that means suppose the processor is working in the 386 mode. The 386 as a 386 processor. Okay. And whenever you want to switch to the 8086, okay, that is high speed. That is the converted. That is it converted 386 to the lower version. That is the 8086. Okay. Then this flag will be the same. That is the virtual mode, because it is switching from one mode to the another mode. That means it is going to the 8086 mode. Okay. That is the previous version of the processor. Okay. So this is the, and when this flag will be cleared, this flag will be cleared in the protected mode, because by default 8086 is operating in the real mode, and whenever it has to operate in the 386, it has to switch to the protected mode, and when it switches to the protected mode, that means this bit will be clear, because it is not working in the 8086 mode, it is working in a 386 mode. Understood? This is the flag registers of 386 microprocessor. Now, among the last, the higher bits, that is the bits from the after the virtual mode, that is after the 17th bit, all bits are reserved. All bits are reserved up to 32 bits. Okay, it may be used. It may be used for the future mode. So this is the flag registers of 386 microprocessor. Have you understood, guys?
Yes.
Okay. Now next. Next. Instruction pointer. Now instruction pointer means what? Instruction pointer means it gives the pointer whatever the instructions get executed. Suppose it gives the current position on that, okay, which is again the 32 bit. For 8086 it is the 16 bit, that is the IP, and here you have the EIP. Now there is a set of instructions, like you have, take a simple example, like you are doing the C programming. In C programming, first statement main, then you have the curly bracket, opening bracket. I think you know the C language, everybody. Okay, so in that main you have the first variable definition. After that next, and then you have the instructions like the printf, scanf, if. So the instruction pointer will point to that instruction which want to gets executed. Okay, which is just going for the execution, So the instruction pointer will point to that, which is a 32 bit, Now the next. Okay, I think this is the instruction pointer. Okay, now next is the. Let's do that. Okay, now this is the another point in your programming model, that is the registers. Okay, then you have the instructions format. Now what do you mean by instruction first? What do you mean by instruction? This is the next point in programming model of 386 microprocessor. First is the memory organization, second is the data type, third one is the registers. In registers actually you have the debug register, test register, but whenever the point come I will tell you. Okay, because it is a little bit confused. So instruction point format. Now in the instruction format, okay, what do you have? What do you mean by instruction first? Let me know. What you have understood in the instruction? Instruction म्हणजे काय असतं? Like your mom has given the instruction that abhi padhai karo, abhi just go for some another work. That is the instruction given by this. Similarly, here in the microprocessor, you have to give some instructions to the keyboard. Okay, so that has some specific format. I think in let me know in the Python. I think in your FDS or DSL subject, I think you have done that. So the instructions has been given in the Python programming also. The instruction has been given to the instruction has been given through the keyboard to the processor. Okay, instructions has been given to the processor. So okay. Now the instructions has been given through the keyboard, like in Python or in C, C++. That is the printf, scanf, if you want to. These are the different kinds of instructions. But for everything, for even the C language also, there is a some format. The format has been specified for each and every languages. So similarly, in a 386 microprocessor, they having some format in there. Okay, so that will be, we will see that. Okay, now this is the format for the 386 microprocessor. Now see here, you have the segment O, right? Then the segment operand size prefix. Okay, then you have the address size prefix and the instruction prefix. The number of bytes, the instruction kiti bytes chain, number of bytes. Okay, so that is the size of that instruction. So first is the immediate, then displacement, then you have the दिसते का नाही सगळ्यांना? हा. Now next is the SIB, okay, that is the zeros and one. Then we'll go through the moderate, STD instruction is there. Then you have the opcode and mod, something like that. Okay, just remember in this instruction format you have a like. एक minute. I will just tell you. एक minute. I will tell you this instructions format. Let me just show you. Now see, here you have a opcode is there, okay, opcode. Like the opcode you have here you have the source and destination is there, okay, source and destination is there. Now here you have the opcode, okay. Opcode means what? Opcode means what? Okay, whatever the instructions you have given. Now for example, in assembly language you have a move instruction, okay. Now here you have the destination and here you have the source is there, okay, source, that is destination. Whatever the content you are moving into from the source to destination, like in this way, okay. And here you have the move instruction. Here you have the move instructions. Okay. So this is the simple format I have shown you. I have explained you. This is the instruction like opcode, source 1, source 2, or the source and the destination and the source. Okay. So this is the particular format in the assembly language programming. This is the particular format in the assembly language programming. Okay. Now next thing is have you understood this? This is a little bit complex actually. Here they have given the address size prefix and all these things. You will understood whenever the next slide will come. Okay. So here instruction prefix is there, address size. You have to mention the address size, then a segment override, whether it is an immediate address, whether it is a displacement, whether it is a direct address. Okay, that we will see next in the addressing. Now next. Okay. Now the next slide is. Okay. Now the next you have the mode, read and write, read mode. Okay. And these are the different kinds of formats actually for the instruction set. Okay, which is maybe 0 to the 8-bit format. This is the 8-bit format. Okay. Now SIB byte format, that means the scale index base. See, this is the addressing mode. You have the direct, indirect, immediate, scale index, index mode. These are the addressing modes of 386 microprocessor. That you have to use in the instruction format. That we will learn in the next, maybe in the next topic. Okay, what are the addressing mode? Why the assembly language will require the addressing mode? That will. But just remember, here you have the scale index base. Okay. Now next, how will you select the operand? Now the operand can be of any location. Operand can be in any location. It may be in immediate, it may be direct, indirect, etc. So in the registers, आता registers बघितलेत आपण. ठीक आहे. आता operand कुठे असू शकतो, कुठल्याही register मध्ये असू शकतो. It may be anywhere. So in the register, all the registers you have, or the base pointer 32-bit operand AX, AH, GH, BH. In case of 16-bit operand, the H, in case if it is a 16-bit, then you have the HAL, BH, BL, CH, CL. That is AH is a 8-bit, AL is a 8-bit, BH is a 8-bit, BL is a 8-bit. So total AH plus AL, it is a 16-bit. Okay. So the segment register or the flag registers for the flag operation, these are used for the flag operation. And this operand will be from the memory only, because whenever you are playing with the registers, that means that is a memory part. Okay. And these operands may be from the IO port also. IO port means input output port. मॅडम आता इनपुट आउटपुट पोर्ट काय असतं, तर that will be your that will be related to your 386 processor. That is through the input port you can give the input, and from the output port, that means it will give the processor will give the output from that port. Okay, like you have the input is a keyboard and output is your printer. Printer is there, then you have the mouse is there, something like that. So through the mouse is the input actually, output is your display is also there. Okay, so that is the next point. Now these are the instructions. Actually you won't understood now because there is a AM instruction, ask adjust for the multiplication, but just remember there is some instruction set. Okay, so that will be related to your. Okay, this is the instruction, that is the AAM, ask adjust after multiplication, operate on the content of X register. These are the particular instructions which will operate on the particular operand. Okay, explicit the operand, that's it, exchange EAX. The operand to be exchanged are encoded in the instructions after the of code. Okay, आता ह्या जेव्हा instructions set येतील, whenever we have a set of instructions, whenever we learn that you will get it. Okay, now just remember this one. Now there is a 2 operand instructions, register to register, register to memory, memory to register, immediate to register, and immediate to memory. Okay, so this is the 386. It permit the operations. म्हणजे बघा जेव्हा इन्स्ट्रक्शन्स तुम्ही लिहिता, जसं C लँग्वेज मध्ये किंवा पायथॉन मध्ये जर एखादी इन्स्ट्रक्शन जर चुकीची असेल तर what it will give, it won't allow you. But similarly here you have in 386 assembly language programming, there is a it has given the permission that you can move the content between the register to register, register to memory, memory to register, immediate to register, and immediate to memory only. Okay, so that is the next thing. आता immediate operand काय असतो, immediate operand म्हणजे you have the direct value is there, so that value you are directly moving into the X register, or the immediate operand is there. Okay, just remember this one. Now the okay, let me know for this memory operand. Now what is a memory operand? That is the data manipulation instructions that address the operand in the memory and must specify either directly or indirectly. Okay, and for this the memory operand, that means you can specify that directly or indirectly, maybe within the segment or without directly operand has been given. Okay, now this is the you have the operand selection. The instruction format we have seen. The operand selection is something like this. Okay, how you can select the operand for the instructions. Now next is the memory operand. Then the segment selection. The segment selection मध्ये पण परत तसंच आहे. काही restrictions आहेत, काही formats they have defined. So data manipulation instruction need not explicitly specify which segment register is it. But suppose there is an option that is for 386 processor, it is a descriptor you can use, and for 8086 it is a code segment, data segment, stack segment. Okay, is there any problem? Somebody is talking, let me know. Yes? I think no doubt is there. Am I right? If you want to give, you can put in the chat box also. Okay, so here you can all memory access if the segment is not explicitly specified. जर एखादा सेगमेंट स्पेसिफाय केला नसेल तर मी ऑलरेडी आय हॅव सांगितलं की फ्लॅट मेमरी असते, सेगमेंटेड मेमरी असते. सो इट कन्सिडर ॲज अ लिनियर मेमरी ओनली. It considered as a linear memory only. Now the next. Okay. Now these are the some rules that you have to follow for whenever you are writing some instruction set. Don't remember this one. Okay. Now this is the address component. Now next is the interrupt and exception. Now what do you mean by interrupt and what do you mean by exception? Interrupt is something like the asynchronous event. Interrupt is asynchronous event which is triggered by the external devices, and exception means synchronous event. This is a synchronous event which that are the responses of the CPU to certain conditions and that are detected during the execution of the instruction. म्हणजे एक्सेप्शन हे सॉफ्टवेअर असतात, इंटरप्ट हे एक्स्टर्नल असतात. ठीक आहे, अंडरस्टूड? ओके. ना आता काय कुठले कुठले एक्सेप्शन्स आहेत, कुठले कुठले इंटरप्ट आहेत, दॅट आय हॅव गिवन द लिस्ट हिअर. Okay, that is divide error, then you have the debug exception, NMI interrupt, then breakpoint, detected overflow, range. These are the different exceptions are there. Okay, आता बघा when there is a divide overflow error is there, so at that time it is not giving the error but it is giving the exceptions. Okay, so some exception numbers has been defined. There's no exception 0, exception 1, exception 2, exception T. Something like that. Okay, now this is the programming model of 386 microprocessor. Have you understood? If you have any doubt, you can ask me. Any doubt? Yes.
मैम फ्लैग रजिस्टर के नोट्स प्रोवाइड कर दीजिए.
अच्छा ठीक है, करते कोई प्रॉब्लम नहीं. I will share all the PPT. Is it okay?
ओके मैम.
Okay, I will share the notes to you. Don't worry about that. I will share my all the PPTs. But have you got it? Programming model. Then what we are learning. See guys, the processor in this subject, they have given some technical, some theoretical. Okay, you have to consider, you have to accept as it is. You can't change it. You are not a researcher. Okay, yeah, there may be, you may be researcher, but after your graduation. Not now. Whatever the concept they have given you, you have to accept as it is. You have to assume as it is. Okay? I think there is no doubt. Have you understood this? I am taking the test on this first unit, guys. And I will ask anybody to. I just taking the within the 10 minutes. I will just ask some question. Okay. So, is it? I will. If you don't have any doubt, then I will stop here. Yes, am I right? Shall I?
Yes मैम.
Okay. Thank you.
Goodbye.